glad I'm here. Of course, I won't be here alone on the stage. I actually have very nice speakers with me, and I'm really looking forward to be able to talk about the future of neurotechnology, both on the consumer side of things and in the medical field, with such a great selection of speakers. And I'd like to welcome the speakers to the stage with me. I'd like for you guys to walk up, and then I'll introduce you one by one. And in the meantime, I can maybe say a bit what I'm really passionate about here at CES, and it's really the human connection and the human interactions. I'm from Zurich, Switzerland, and I don't really often get the chance to see these lovely people face to face. You know, a lot of the neurotech space is happening in the US and in other countries, so it's great that we have the chance to all be here together. Are we good? All right, okay. Can we have one more mic maybe? Is that possible? All right, so while that hopefully happens, I'll get the speakers introduced. So welcome to the Everyday Neurotech Brain-Computer Interfaces for All panel. And I'm really looking forward to be talking about the everyday part of BCIs and the for all part of BCIs. So I'm hoping to hear something about that there. Left to me, I have Tan, and Tan is the CEO of Emotiv, providing wireless EEG devices and software for research, education, and BCI applications. And Emotiv launched their MW20 EEG active noise-canceling earphones at CES, so I'm very excited to hear more about that. And then left from her, we have Jessica Randazza-Pade. I'm happy to pronounce that in Italian as a Swiss person. And she's the VP of Marketing at Neurable, who are the creators of the MW75 Neuro headphones for focus and productivity through EEG and AI. And then to the left, I have Jason McKeown, sorry for butchering that last name, CEO of Neurovalens, developing non-invasive neurostimulation devices for chronic health conditions. And they just launched their Modius product for sleep. And then I have Tam Vue, professor at Dartmouth College and founder of Earable Neuroscience, also the creators of the Friends Brain Band for sleep improvement using neurotechnology. And then last but not least, we have Kimi Doan, Chief Innovation Officer at Earable Neuroscience, specializing in innovative sleep wearables. Can I get an applause for these amazing speakers? Thank you. All right, so I brought a couple of topics I would love to cover with you today, and something that I want to kick it off with is the recent advancements in neurotechnology. So as the panel title suggests, we want to build neurotechnology for everyone, for the mass market, and I guess we would all agree on the statement that the time is ripe to bring solutions to everyone. So I'd love to hear a bit about how your companies are contributing to the newest advancements in the neurotech space, or also in general, bigger topics that are happening in the industry at the moment. And I guess I'd love to get started with you, Tan, if that's okay.
Yeah, sure. So we've been around for some time and have been democratizing the space around neuroscience in over 140 countries. So we support all forms of neuroscience research, whether it's looking at accessibility, some of the clinical applications, education, a very broad spectrum. But one of the things we're very excited about just this year at CES is we've just launched these new true wireless EEG devices. So if you look at these devices, super small, very inobtrusive, it really integrates seamlessly into everyday life. And I think this is one of the biggest trends that we'll see is around miniaturization and allowing true connectivity that will allow us to continuously monitor what's going on in our brains, because that's the key. The challenge with EEG is that we're contending with a very surface measurement, and for the last decade we've been dealing with scalp measurements, so dealing with measurements on the scalp itself, which means we have to measure very small signal through the skull, which basically think of it like a thick wall that you're trying to measure through. The lovely thing about the in-ear, and you guys, IDUN, have also done an in-ear system. The great thing about an in-ear system is it's like a window into your brain. We don't have a skull to contend with in this region, and so we can actually see inside, and this provides terrific quality measurements. And at the same time, because of the benefits of wireless computing and signal processing on our phones, we can do so much more. And so I'm really excited about that, because you can then combine that with machine learning and AI to provide a lot more insights for consumers.
Lovely, thank you very much. I guess, Jessica, if we look at what Neurable's doing, it is a bit of a different form factor, right? So maybe you could also share a bit how that kind of makes sense in terms of an over-ear form factor.
Sure, yeah, I'd be happy to. So we actually are agnostic at Neurable. So we have partnered with Master and Dynamic to develop this over-the-ear headphone that are beautiful. Some of our Master and Dynamic partners are in the audience. Hi, guys. And they are really meant to help, as Tan was saying, to democratize the technology. So we are really interested in getting people comfortable with something that they already use in their daily lives. But for us at Neurable, we are really a software solution. So we're an AI technology that is boosting brain signal that is found around the ear, in the ear, to be able to give you an accurate reading of your EEG. And so what has traditionally existed and some of the technologies that are here today, it's frontal lobe, which is a great place to get EEG signal, which has existed traditionally. But we are really looking to be able to clean the data in such a way that you can simply put this on and go. And so for us, we have then this partnership, as I mentioned, with Master and Dynamic, but we're also working with the Department of Defense to integrate it into things like hearing protection and also into things like helmets so that we can better understand things like traumatic brain injury. And working with partners like the government is going to help democratize it and commercialize it even further.
Thank you. Do we just want to carry on? Yeah.
Sure. So how we would look at kind of neurostim, and I'm maybe overly generalizing here, but hello. Yeah, sorry. So maybe overgeneralizing a little bit, but whenever you look at neurotech, particularly in the wearable space, you sometimes have devices which read data or read stimulation or read parameters from the body, and then you have devices which deliver stimulation or data to the body. The other part of that is you have do devices want to be medical devices or non-medical devices? And just to kind of paint a picture of where we're at, so we only apply stimulation to the brain non-invasively, and we are very much a medical device. And we have a range potentially of treatments coming out, but the two that we have clearance for already are a treatment for insomnia, which we've just launched now, and that's a prescribed device. Doctors are prescribing that across the US currently. And we also have a clearance for a generalized anxiety device. And then later this year, we're hoping to actually also get approval for PTSD. So across that sort of range, as I say, our focus is very much creating medical treatments, defined populations, the patients, we can say exactly who they are, who they should be, who they shouldn't be, and then if a doctor wants to prescribe instead of, say, using drugs, they can do so. And yeah, overall, as I say, what we're trying to do is just build one piece of technology, but multiple approvals then as we go through.
Yeah, I'm Tam Vue. So yeah, at Earable Neuroscience, we've been spending the last decade, 13 years to be exact, to develop and understand the system around the ear, and that's why we have the name of Earable Computing, right? So at University of Colorado, and then later at Oxford, and now in Dartmouth, what we're really focusing on is trying to extract important information from the ear, and then using the same area, the same portal, to sending in the information and send in the stimulation that can help to improve humans' cognitive functions, right? So going back to Simon's question about the recent advancement in neuroscience, I think there are three main pillars that we have been seeing, we continue to see in the future, that are the advancement in sensing, that help us to understand and look into the brain really, really well, non-invasively. And the second is then applying those AI, machine learning, especially the advancement of neural network, into making sense of those and understanding what's going on in the brain, what are the cognitive functions, what are the cognitive level that are being changed. And the third pillar is going to be the actuator, the stimulations. Can we use speakers, when we use ultrasounds, among many other kind of stimulation that can interact with the brain to improve our brain and cognitive function. So that I would see are the core pillar that we'll be seeing in the next 5-10 years, and we're happy to be part of that.
Yeah, I do agree that I think everything is surrounding the form factor and how to make it into the consumer market. And the fact that this year is the very first year that we have the NeuroTech track, thanks to Modev. And when we have a line of own up solutions in here, I think the form factor, how to make it into the daily life and integrate that as part of the activities of the consumer is a very important part. The second part is that how we can integrate AI seamlessly into the user experience so that when they use the device, it's not about playing with the technology, but instead it's a part of their daily life. So for example, for me, when I wear the wearable like this, we designed this from Earable Neuroscience, we designed it from the sleep perspective because we think that we start the day with the good night of sleep, not in your morning time, but you actually start your day at night. And that's why we start with the form factor so comfortable and so soft and ultra soft so that people can wear this during sleep and whatever sleep position. We start with that and we spend a good 10 years making that innovation. And for the last 2 years of winning CES innovation, I think we have been focusing on the sleep, wellness, and so on. But starting this year, then people will ask, okay, what can we do during the day with this? And we start to see focus and how to boost your performance and cognitive performance.
Something that I see as a bit of a challenge in the consumer neurotech space, or I guess in neurotech per se, is the trade-off. We heard a lot about form factor innovation, right? And how devices are becoming smaller and more comfortable. We do have to address also that with devices, becoming smaller, having less contact area to the skin or less electrodes, less channels, that there is a challenge from a signal quality or from a data perspective. So this is something which kind of leads me a bit to the second point I want to discuss today. We all have raised funds, I believe, in our startup life or company life so far. And I guess the question that I probably have heard the most from investors is, what do you think is the killer application in neurotech? And considering these trade-offs, I'd love to hear from the panelists here what they believe potentially moves the needle today for neurotech, and also a bit of the big vision, 5 to 10 years, how they believe that the world will be changed by the technologies that we and hopefully a lot of people here in the room are building as well. I'll just pick randomly, I guess. Let's start with Tam again.
Sure. It's always hard to predict what the killer application would be, right? But I think if we look at most of the application that has been adopted based on cutting-edge technology, we see the common thread, common patterns that you pick an application that already have solution, but it's not perfect, have some drawback, right? And then the breakthrough, the killer app would be able to solve that small corner to make it mass production. So I think in our neurotech world, a good application would be a drug-free solution for something that's already being solved right now in the pharmaceutical world. Pick insomnia, ADHD, some of the neurodegenerative drugs that are being treated by using pharmaceutical solution, using wearable, using new neurotech technologies. I think that would be the killer app that we would see in the next 5-10 years.
Who wants to follow?
I'm happy to go. I think what makes this really exciting is that BCI has the ability to be as adaptive and tailored to each of the uniquenesses of our brains, right? So using the EEG signal, we can really better understand you and tailor to you. So one of the things that we're exploring, and I expect to continue to see in the next set of years, is opening up platforms more, and I know Emotiv does this, to developers, to allowing for there to be more people coming onto the platform to allow for different kinds of applications that are tailored to people's different needs. And I think that's really exciting. So I hope to see in the next set of years that there are applications that we couldn't visualize sitting here today, that are really helping people in new and meaningful ways.
Yeah.
Yeah, so absolutely. The ecosystem is very important in ensuring that there is a wide variety of diverse applications that can leverage the underlying platform technology. But as the company that puts out the technology, first and foremost, we do need to seed it with some basic applications. And so the way that we frame up the opportunity space is to look at two things. You guys are all here because you're interested in brain-computer interface. I assume that has something to do with moving stuff with your mind. So Emotiv was one of the very first companies that pioneered this, and we have, with our more dense array systems, people playing computer games like the very difficult Elden Ring just with a mind controller, or having a person who is paralyzed from the neck down drive a Formula One car using his mind. We've ported that technology now into this form factor so that anybody can actually start to move objects with their mind, both virtual and potentially connected to physical objects as well. So things like an IoT, so you can change the color of your lights, move things around in a virtual world. So I think those are some of the things that will start to move this technology beyond just the clinical and medical healthcare wellness space into something that will become much more mainstream for consumers, because the gaming market is a very substantial one. But at the same time, as we add some of these applications around entertainment, it can also support the underlying health benefits that we're trying to drive at. Because at the end of the day, I started this company because I want to advance brain health for everyone. We are all not going to live to 100 years in a way that we want to if we can't preserve our cognitive resilience and our cognitive health. And this means that we need to put technologies like this into the hands of everyday people so that we can start to track and improve our cognitive well-being. We can make better choices every day that ensures that our brain remains healthy for as long as possible. And that's really, really hard to do unless we start to measure and track our brains. So I'll give you a very specific example. On this panel, we all have what is called inter-subject variability. Simon's brain is different to mine is different to Jessica's, and so on. But at the same time, there's also what we call intra-subject variability, meaning my brain over the course of my own life will change based on the things that I do every single day. And so let's say, for example, I've been tracking my brain. I can compare my brain to everybody else. That's really helpful to benchmark my brain. But if something was to happen to me, let's say I went out, got concussed for some reason, a mild form of traumatic brain injury, and my brain's performance was impacted. Today, we have no way to benchmark that, because if I was a high-performing person, the standard norm is too broad, and it would not be able to pick up my deviation from my own norm. So that's the challenge we have around this room. Our standard norms do not reflect our individual norms, and until we start to track our brains over time, because the system is designed to adapt and change over the course of your life, it's much, much more difficult from a science perspective to be able to study and improve the state of our own individual brains unless we can start to track it sufficiently. And that's what we're trying to solve for. And I think everybody on this panel shares the same aspiration.
So, sitting here and I guess looking a bit into the panel here, I can't help but notice that I guess maybe Jason, for you, having a more very specific medical approach or strategy, I'd love to hear your perspective on go-to-market strategy, pros and cons, business models, because what you, Tam, just said before with, us as companies building the tools so others potentially can also build the applications with the developers, as Jessica mentioned. this is pioneering, right? Potentially there aren't many example companies that have scaled massive businesses in this industry. So this is a bit of a pioneering work, which might be a bit different in the medical space. So I'd love to hear your perspective on how your company has been approaching the go-to-market and how that potentially differs from our companies.
Yeah, I think every neurotech company will have challenges when trying to go out and raise funding, and ultimately you're convincing investors that your idea or you believe this process will result in something that's going to make them a return. To be frank about it, the additional challenge when it comes to medical devices is there is a long period of R&D before you can ever enter the market. So until you really have FDA approval or clearance, you don't have anything. So you're really trying to convince investors or investors who understand the medical device process, the long, expensive journey, and the risk that they are taking, maybe depending on a single clinical trial, to take you from a non-commercial company to a company that can commercialize. And I think that is definitely challenging. We've been very fortunate, actually, that our investors understand this. So what we would have done is try to maybe lay out milestones, like even recruitment milestones, or try to get maybe parallel trials running. So it's not always dependent just on that absolute gold star of getting the FDA approval. But then once you get the FDA approval, then you move into other challenges. And the biggest one, and to kind of touch on your previous question, the biggest thing that we would see that potentially could move the needle for neurotech in the medical device space is better reimbursement. So traditionally, non-invasive neurostimulators don't get great coverage when it comes to reimbursement. And as a legacy of that, any new device that kind of comes in subsequent almost gets put in that same bracket. And that's very much potential issue for us whenever we go to commercialize and we go and speak to insurance companies, that we're almost branded in this same light. So what I think would, yes, it's challenging. Once you get the approval, there are multiple challenges, but I think, what would move the dial for us going forward would be successful reimbursement outcomes.
As a company that have launched a product into the consumer market and making a pivot into the B2B world, what I want to add is it's really a trade-off whether you want to go to consumer first or you go to through clinical first and get the FDA approval first, because it's really about how long can you sustain, how long can you raise your funding without really delivering, right? I think what Jason was mentioning is really that he was lucky enough to have a great team of investors who really understand how long it would take for getting through the FDA approval and then getting reimbursement, right? We, on the other hand, very early on, we would have investment from Samsung as a big consumer play, and they really wanted to push through toward consumer, right? So I think it's really a mix of, it's a right trade-off between how mature the technology is versus the taste and the taste of the investor is, right? Yeah, but of course it's come with rewards. If you can run that long without revenue through as a medical device, then it's easier to get into the market once you get the approval.
So have you considered going for a medical certification at some point in time, and what ultimately made you go in the other direction? Maybe Kimi, for you?
Yeah, I can add with that, because like originally our intention was always going into the B2B and research, given our depth in 10 years of innovation and making this, but we were launching into the consumer market, kind of like a scientific piece of device in disguise as a wellness device. And that's how we, for the last 2 years, we were gathering kind of like real world feedback from the users who actually like pay for this, not as a gadget or a toys. Like 90% of our consumers, they actually have insomnia. They are very, very well educated. We call them like prosumer, right? And they are very well educated about their problems, and they are actively seeking the solution. So when we have like those kind of market validation and feedback, we found that it's also very crucial and also very important when we come to our B2B partners and doing our publication. So it's kind of like we are running in parallel. But our main, you cannot like choose both, because like both of them have like very different roadmap and strategies and resources that we need. So far I can see that like our consumer is kind of like more short-term, like sustainable way for us to be in the market, keep the branding and so on. But like our strong standing point could be in the B2B and medical world, and we already follow the FDA framework. Yeah.
Yeah, I guess something that is potentially a bit unique in the neurotech space is that to some extent everyone is on a scale a patient, right? And something that I find challenging is a lot of the technologies that we're trying to build also in the consumer space, they're ultimately multiple panelists here have mentioned that they're for the brain health, for the good of people, and it is, in that sense, it is a health product. But the regulatory landscape, at least in my opinion, is challenging sometimes as well. I remember multiple conversations we had. So we're, as mentioned, we're a Swiss company, so we fall under the European MDR, which is a bit of work these days. And we have talked to large companies like Eurofins, for the medical certification, and they couldn't really tell us, is this a medical product? Is this a consumer product? How do you certify it? So this is another challenge that I see for neurotech companies. Like, you want to do good, but it's really not that clear how you actually go there. And from a certain perspective, products can be seen as a consumer device, and from a certain perspective, potentially as a medical device. And this is, I guess, more my hope also for us, but also for everyone here in the room to innovate also on how we're certifying these products and how we're thinking about a consumer product and a medical product. Because ultimately, I think, preventative health, it starts very early on, right? And also in the, earbud space, thinking about a consumer earbud product or a headphone product, this is first and foremost a consumer electronics device, but it can be a health device as well. And this is something I think could potentially be really important in the future, how this is being regulated. Maybe Jessica, on your end with Neurable, was that a conversation at some point, medical, consumer? How is your team thinking about that?
Yeah, I mean, I think we are not seeking any type of FDA approval at this point. Our play is really working with partners and OEMs and to work through those channels to get licensing of that kind. And certainly there is a lot of application in our technology for a medical device. And so we're talking to partners about what that might look like. But we won't be the ones specifically seeking it in the short term.
Very good. Then something I also want to talk about today, and I know that for some, potentially for all of the panelists, this is a topic which is very close to the heart, is neuroethics. And I'd love to hear your opinion on where does neuroethics stand today. I purposefully leave the question a bit open. Where does neuroethics stand today? What potentially needs to happen? What are the chances, opportunities? What are the risks? And Tan, let's start with you. You have seen a lot in the market, right?
I have seen a lot in the market, and we've been very active stewards of this space, and I've personally been very active in neuroethics policy making with the OECD and with other organizations, with the World Economic Forum in their Global Future Councils on neurotechnology. So we have to stay very, very actively engaged in the conversation because we are shaping the future, and this is one where a lot of people care about the ethics of what goes on. I think from our standpoint, the fundamental position we take is that brain data is users' data, right? That means that the users need to have full control over the privacy of that data, what they want to do with it, right, and how they want to use that data. So for us, in order to provide a service to our customers, we may collect a copy of that data to improve the service for our customers, but we make it a very, very basic premise that we will not share that data unless the user authorizes us to share that data. Now, when the user authorizes us to share that data, it can only be shared when they open that very, very specific application for that very limited period of time. We won't share everything because we know that consumers will just generally click through EULAs without really going through and thinking about the impacts of what they're sharing. We take data security very important, very, very highly. We rate it as super important. So we have now got ISO 27001 certification. I believe probably one of the very first in the neurotech space to have independent third-party audits of our system for security management because we think it's so important. When we're training our models, we do pseudomize data, right? And that's really, really important for consumers to understand. If we do have a copy of your data for the purposes of helping you understand how your brain is progressing over time, we will pseudomize it so that we don't know who you are anymore, and then we will analyze that data along with many, many others, because quite frankly, we don't care that it's you. What we care about is how does it change over time and how does it compare to other people who have who may be in the same age bracket, who may have the same types of education. And so there may be metadata that you choose and you elect to share. Now, at the end of the day, the most important thing that we need to do as a provider of service is to ensure that consent is properly obtained. That means that we need to make sure that when we are designing our products, our customers understand when they're sharing data, what data they're sharing, and that's really at the point of the product design, right? So you make sure that happens, and so we try to do that, and we try to educate our customers. At the end of the day, it's a two-way street. So if customers are not thinking about that, and then they're just accepting through, then that's something that's quite difficult for a service provider to provide. But I think that's best practices today. But at the end of the day, this is a moving space, which means that we have to stay vigilant. We need to stay active. We need to stay very present and maintain a dialogue with the community, because as expectations change, as the regulations change, we also need to change along with it. So we're very aware of the fact that we are in a very nascent industry that's continually evolving, and whilst we may have the best interests of everybody at heart in order to make sure that this industry survives, we can only do the best that we can at this point.
Yeah, so Neurable was founded by a neuroethicist and a neuroscientist. So at our core, we're very, very interested in how neuroethics come into play with neurotechnology. And we take the stance that, similarly to Emotiv, that the user data is theirs. But the thing that we do that is slightly different than that is we actually don't take their data unless they allow us to take it. So they have to opt into that, and then it is anonymized. And so we will then take that data and aggregate it into better understanding benchmarking and that sort of thing. But that is a step that they have to take to opt in for us.
Yeah, I can add a medical slant on this again. So, whenever we even start conceptually looking at clinical trials, we actually have to submit the whole proposal to a board, an ethics board, for their review. So it starts there, and then it actually works right through to approval. But it doesn't even stop at that point, because there's even ethical questions around the right doctor prescribing to the right patients, us being clear and absolutely who this treatment is for, but also who it's not for. And then, it's been touched on already in the panel, adding into that then patient data and the ethics around knowing, say in our case, their kind of medical history and what we do with that and how we handle that. So I think everyone's going to say this on the panel, but yeah, absolutely, the core of what we do has to be complete ethical practice. In the medical world, there's that additional little part where we actually have to submit all of that to a board and get approval before we can do anything.
Yeah, from research and development perspective, the ethics is also have been taken very, very seriously, especially in educational environment like Dartmouth or in Oxford. So we always start with the ethic board, right? Getting IRB, making sure that the data, everything is following the procedure. But the key there is actually the person, the human-centric approach. We have to inform the person about the fact that the solution is still, for example, under development. We have to disclose all the potential outside, especially when you do a stimulation and when the solution is still, again, under development, right? So the difficult part, which is still we have to take that into account. And the challenging is coming from the human factor into that, right? Making sure that they understand what they're getting into, how their data will be used, and we do our best, right? We do our best, and especially again under education or other organization, that even need to be taken even more seriously. And that's what happened at Earable Neuroscience when we were under Oxford or when we were under University of Colorado as well. Yeah.
Yeah, I think that in terms of the neuroethics, we haven't had any kind of like standardized requirements, and that's why like when we can refer to is like the consumer electronics as well as like health data. What we are already collecting is kind of like the biometrics, right? And the bio data. So we follow very thoroughly with the framework by FDA recommendations in terms of the data security. And additionally, when we publish the app on like Apple Store or the Android marketplace, I think the most important is about the opt-in and opt-out options for like the end users, as well as like being very transparent about like how the data is being used and how we can like make the data more unanimous. Yeah.
What I'm hoping to see more in the neurotech space when it comes to neuroethics is practical tools, because it can be a bit of an abstract topic. And if you go to our website, idun.technologies.com/neuroethics, we do have some practical guidelines, acceptable use policies, a partner rubric, which we're happy if people use that, because it's sometimes challenging to break this topic down to something meaningful, and especially if you are in the B2B space, which some of us are, you do have a partner, right? And it also depends on what the partner wants to do, and it also depends on what's in the wallet of the partner, right? And you know, then you have the challenge sometimes as well. And I think thinking about these topics beforehand might really be helpful. We have a couple of minutes left. I'd love to spend the last 3 minutes of the panel on the topic of AI, artificial intelligence. One kind of has to these days, I guess. So what I'd love to hear from each and every one, maybe one sentence to go or maybe two, is where do you see the big potential of AI in the neurotech space, specifically some of the challenges that potentially can be solved by it? Let's start reverse order with Kimi.
You can see my excitement because this is like really the most interesting topic. We position ourselves as the world's first AI-powered like consumer wearable. And for the last 3 years, we have been applying AI for personalization. So based on the brainwaves, because we think that the user shouldn't be like have to do anything. Like the AI should be able to like really develop and evolve along the way with their habit and with their progress in terms of like how they are being solving their problems. So I could see that like the progress of AI, generative AI, as well as like more of the content that AI could be applied in healthcare could be our next step in revolution.
Well, I think AI transformed neurotech from a toy or a device that tracking into an actor that actually helped, that actually act, that actively being part of the solution, right? And the reason is AI help the device to become a lot more smarter and reliable. Unlike before, I mean, as a computer scientist, right, I spent the last 15 years working on AI and machine learning. And the key distinction between machine learning and AI is that, especially with the neural network now, it's a lot smarter, and it's learned by itself through the abundance of data. And that's why at the beginning I was emphasizing on the fact that because our technology now are so good at capturing very high quality neural signal, and that feed into the AI machine that make it, they can decide what's going on and then take action. So I think that the key, the transformation that AI is promising us, right? And that's what we are working on to really harvesting that, play the more active role of the AI in the system.
Maybe one last quick sentence from each and every one.
Yeah, I can be really quick. So we would look potentially in future at adding AI to provide a closed loop treatment approach. So our device delivers stimulation. Another device could be a panels device or something like a watch, whatever tracks, say, insomnia changes that night, and then the next day, the detection of how you have responded to that then changes the parameters in the head or in the headset, sorry, and then it goes sort of back and forward.
Yeah, I think we see AI as augmented intelligence, not artificial intelligence, and it's really about helping understand, as Tam said, understand more quickly in order to find solutions that are going to be more meaningful more quickly.
Yeah, so most of the panel's thinking about the application space and how we can apply AI to the user experience. We are much more interested in the foundation model opportunities for AI as it applies to brain data to create a single model for healthy brain development as well as deviations to the norm. So really, instead of doing these single-purpose conventional machine learning models that are very, very brittle, having a single model that's built on much, much larger scale data that can actually be a universal model for all brain conditions, and we think we can get there.
Mm-hmm. Yeah, I do believe 2025 will be the year where we see some brain foundation models already deployed in the market. We'll see. Thank you very much to the panelists. That was very interesting. Thank you very much. Thanks for listening. I hope that was helpful, and have a wonderful day and CES.
Let's give this panel.